Good afternoon, class. We are starting section 7.5, Sum and Difference Formulas in Trigonometry. So we've covered analytic trigonometry. We covered a bunch of sections, such as inverse trigonometric functions, equations, identities, and we're going to look at more formulas. I really can't emphasize this enough. As you know, trigonometry has a lot of formulas. So we are going to establish the sum and difference formulas, okay, for sine, cosine, tangent, and see how it works, and solve some equations involving those. For example, we covered some identities that are known as fundamental identities, such as reciprocal identities or Pythagorean identities. Inverse functions, and the fact that none of the trigonometric functions is one-to-one. None of them has an inverse unless we do the restriction of their domain. We did that. And in short, for sine, tangent, and cosecant, we go from negative power 2 to power 2. For the rest of them, we go from 0 to pi. All right, so here's the section, and here's the synopsis of the section. Sum and difference formulas are as follows. So let me stop the video so you know when we stream it, it is easier for everybody to watch. So these are the formulas that you really have to get comfortable with. And what we are going to do, we are going to look at the proof for them. So as an example, cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. For cosine of alpha minus beta, it becomes the sum of the two. Sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. And for the difference, you take a negative sign in between. For tangent, is tan alpha plus tan beta over 1 minus tan alpha tan beta. So we're going to look at the proof. We're going to start for the proof of actually the second statement. And so with that being the case, we can establish the rest of it. Okay, so we're going to prove these identities. And to do so, we start with a unit circle. And we are going to consider the two angles, alpha and beta. So first, we are going to, since we are interested in alpha minus beta, we are going to make life easy and choose alpha such that alpha is larger than beta. And both of them are in standard position. So I hope everybody can see the larger angle alpha, okay? Everybody can see in their standard position, it ends up with P sub 2, okay? That represents that angle, if you will. Whereas beta is the smaller of the two, okay? And P sub 1 represents that point. So let's look at those points and understand what the coordinates are. This is a unit circle, everybody. Therefore, the coordinates x comma y are represented by cosine comma sine. So P sub 1 is represented by cosine beta sine beta. I hope it's clear to everybody. Okay, does that make sense? Okay, if we get one of them, then the rest of them go very fast, Nice and easy, okay, class? So that's why I want to spend enough time on this to make sure that we are comfortable with this. So everybody can see alpha, everybody can see beta. P1 has x coordinate cosine beta, y coordinate sine beta. P2 has x coordinate cosine alpha, y coordinate sine alpha. It's very clear. It's just from before where we established the unit cell. Now we are going to come up with an angle of alpha minus beta as follows. Okay. If that is the case, then this point, which we are going to call P sub 3, this one, is represented by cosine, comma sine. Cosine of what? Alpha minus beta. Sine of alpha minus beta. Before we move on, is everybody clear what happened here? So just a quick recap.
Yes.
Excellent. Thank you so much. Excellent. First and foremost, we come up with two angles, alpha and beta, and we choose it such that alpha is larger than beta. We can see the beta, we can see the alpha, and since we are establishing this identity class, we are establishing this one, we choose alpha to be larger than beta, okay? And so we are interested in cosine of alpha minus beta. We also do the same thing by putting it in standard position, a new point having coordinates cosine alpha minus beta and sine alpha minus beta. So what happens when we do that? Because the two angles are the same, okay, then the distance between the 2 points, okay, must also be the same. What points? From here to here, P sub 1 to P sub 2 has a distance. A to P sub 3 has a distance. They are identical. Why are they identical? Because they cover the same angle. Okay, they are both central angles. Okay, since the angles are identical, okay, the arcs are identical, the line segment that extends from one end to the other one are also identical. We are practically done. When we establish this, all we have to do is use the distance formula, and I hope everybody remembers the formula for the distance formula, okay? So the distance between the two are given as follows. Cosine alpha minus cosine beta quantity squared plus sine alpha minus sine beta quantity squared. This is the distance between P1 and P2. Hope everybody can see that this is P1, P2, right? Using the distance formula. The distance formula was what? X sub 2 minus X sub 1 quantity squared plus Y sub 2 minus Y sub 1 quantity squared under the radical, okay? And here's the formula that represents the distance between A and P sub 3. Just write it underneath here. A P sub 3. This is the distance between the 2 points. What does it mean? Well, if we want to write the distance formula for that, okay, the difference in the x coordinates, cosine of alpha minus beta, okay, minus 1 quantity squared, plus sine of alpha minus beta minus 0 quantity squared is the distance. The two are identical. It is easier to use that without the square root. So therefore, we are going to write that they are, let me just erase this class. Okay. So I'm going to put this one is P1, P2 here. Okay. All right. So the two are the same, and all we have to do now, we use our algebraic techniques to square both sides. I hope everybody is comfortable with that. So when we square the left side, okay, we get cosine squared alpha minus 2 cosine alpha cosine beta plus cosine squared beta. That's the first one. When we square the second parentheses, we get sine squared alpha minus 2 sine alpha sine beta plus sine squared beta. We do the same thing to the right, and this is what we get. Okay, so again, I believe you have this completely posted. I want you to pay attention to what we are doing. Okay, so as an example, this portion is the same as this portion. Okay, in any event, so what we do, we are going to collect like terms, and we're going to drop the identical statements if we see on both sides and see what happens. Okay, so all we have to do, rewrite things, and here's what's going to happen. Cosine squared alpha plus sine squared alpha. Okay, let me actually now use a different color to establish this so everybody understands what's going on. Use this one. Okay, so cosine squared alpha and sine squared alpha. We are going to put this one together with this one. Okay, class? Minus 2 cosine alpha cosine beta sine alpha sine beta. Now here, let me use a different color. We are going to put this one and this one together. Okay? And finally, okay, so that's the second one, and we are factoring the negative 2. Finally, we are going to put this one with the asterisk put together with this one with the asterisk. Okay, so that's what's happening. Okay, then what do we do on the right side? Again, let me use a different color, maybe this time. Cosine squared sine squared, okay, we put them together. This is the right side, class. Okay, and so what we notice is that some of them, they add up accordingly. Okay, so if you look at the left side, okay, now let me use another, okay, color. Let's see what maybe we can grab a yellow one. Okay, so what is cosine squared plus sine squared? 1. What is cosine squared plus sine squared? 1. I hope you can see that. What is cosine squared plus sine squared? 1. So on the left side, you have 1 and 1, and then minus 2 times the parentheses. On the right side, you have 1, and then 1, which is 2 minus 2 cosine alpha minus beta. So I hope everybody can see this, okay? So we can cross out the 2 from both sides. This number 2 and this number 2 are identical on both sides. We can drop it. So the other two statements must be identical. We can factor out the negative 2 from both sides, or we can say we're going to divide both sides by negative 2. So I hope you see right now what is left. If you divide by 2, you get the proof of the second statement. Cosine of alpha minus beta equals cosine alpha cosine beta plus sine alpha sine beta. Is everybody following this? Is there any questions? Now, understand, I'm not going to ask you to prove things like this complicated. But what I'm asking you is to be able to follow the steps and see how previous identities that we have established will help us establish new ones. Is everybody okay with this?
Professor, I just have a question. I kind of got a little lost towards the end. Are you trying to make the left and the right side equal again?
We're going to prove cosine of alpha minus beta is cosine alpha cosine beta. We are going to prove this one, okay? Look at it. That's what we want to prove, right? The one with the yellow asterisk, we want to prove that. Is that right?
Okay, yeah, yeah.
This is it. We just did that. I want you to see, okay. We went through the steps. Is everybody okay with this step? Yes or no? Everybody followed how we came this far?
Yes.
This far. Good.
Yes.
Okay. So we started with the distance formula. We came this far. Can you see if I drop the 2 from both sides and then I divide by -2, I get the statement that I'm looking for? Come on, can you see that?
-2. No, I'm not seeing the very last step. I'm sorry.
Okay, no worries. I want to make sure that, do you see this one? Yes or no? This one. This one in the yellow box. We went through step by step and we ended up with the yellow box.
Yes.
Can you see the yellow box?
Yes.
Everybody can. Good, good, good. That's good. So here's what happens after the yellow box. I'm going to write it, then I'm going to erase it. Look at the yellow box. I see number 2 on both sides, so I'm going to write. Okay, let me use a different color. This is fine. So now this one, I'm going to drop the 2 from both sides, and I have -2. Okay. Cosine alpha, cosine beta, plus sine alpha, sine beta, equal -2 cosine alpha minus beta. I'm sorry, this is as good as I can write. My apologies. Is everybody following this one? Because I just dropped the 2. Yes or no?
Yes.
Yes.
Good. Excellent. So here's, I'm going to use I'm going to use a different color. Now I can divide both sides by -2. Yes? Can I do that?
Yes. And then
Okay. Isn't that the statement we were looking
on
for?
the top, yeah.
Look at the top red one or purple one. Isn't that the same thing?
Oh, yeah.
Mm-hmm.
You're done. That's it. It's just that we wrote it the other way. We wrote, instead of writing cosine of alpha minus beta equals to the right side, we wrote the right side equals cosine of alpha minus beta. It makes no difference, okay? So I'm going to erase this so you can see the result. Can I assume we are done for this part?
Yes.
Yes.
Excellent. Excellent class. Let's. Okay, so. So we established the identity, okay? We established the identity. Maybe, it's better to write the other way around. In any event, so this is it, okay? We are going to prove the next one, everybody. We are going to prove the next one. Now, what is the next one? We want to prove the green one, the first one. Are you with me? So now that we have established this, here's the trick. Here's the easy way out. It's going to happen very fast. You want to pay attention, class. We want to prove cosine of alpha plus beta is equal to cosine alpha cosine beta minus sine alpha sine beta. Okay? So we are going to write cosine of alpha plus beta. We have established for the negative one. Everybody agrees that cosine of alpha plus beta is the same as cosine of alpha minus
Negative beta.
negative beta. That works for everybody?
Yes.
Now, look at the purple formula. In purple formula, alpha remains unchanged. Beta will change to negative beta. Do we see that, everybody? Look at the purple. We just proved. So we are going to use the purple formula.
Professor, so all you did was make beta negative?
Yeah, because class, don't think of this as a, think of, why don't you do this? How about let minus beta, okay, let me use a different color. I don't want to use that one. I'll use a green one. Okay, how about this? How about if negative beta is the same as theta, let's say. So if I had a theta, everybody can see that I would use theta here. I would use theta here. That would be fine. Yes or no?
Yes.
We're using negative beta. This is the trick. This is a basic algebraic trick, okay, class? So you are going to replace the beta with negative beta. Is everybody okay with that? Okay, I see that some students are uncomfortable with that. This is algebra. This is no longer trigonometry class. What I'm saying is, do you see the plus beta? If you see plus beta, it's the same as writing minus something. I'm going to use that something from now on.
Okay.
And that's minus beta. So why am I writing minus something? Because I proved the formula for the negative. Because I proved it for the negative, I wanted to make it look like that. That sounds good, class? I need to move on, class. There is a lot more to be done. You want to go over this and see the algebra behind it. In any event. Now, what is cosine of negative beta? Okay, cosine of negative beta is the same as cosine beta. Why is that? Because cosine is an even function. But sine of negative beta is minus sine beta. Okay, so let me erase the theta here, and I want to make sure everybody understands what happens here. This is the same as cosine beta. This is the same as negative sine beta. And that's a proof for the green one. Is everybody following that, class?
Yeah.
Okay. Do me a favor, make sure that you study this page and understand the concept, because the proof, I hope you see that the second one in purple, it took some time to prove it. And I don't expect you to prove it, but I do expect you to understand the green one, and it really should take a split second. All I'm saying, look at the purple one. We have already proved it. So how do we prove the green one? Well, instead of plus b, I'm going to put minus b, or minus beta. And so in the purple formula, anywhere I see beta, I replace it with negative beta, and I'm done. Because we're going to use the same in the next example for the proof of the sine and tangent. So you really have to understand this. I'm going to move on, class. I suggest you look at this page, and study it for a couple of times, and then you're more than welcome to come to the office hours and ask me questions. We need to move on. So here's the next one. So how do we use this as an example? If we want to find the exact value of cosine of 7 pi over 12, it is not a basic common arc. We have the answer. we cut it into pieces such that both are common arcs. And if you have a hard time seeing what adds up to 7 power 12, change it to degrees. You can easily see that, class, okay, if need be. So we need to see that it's the same as pi over 4 and pi over 3. I wrote as 3 power 12 and 4 power 12. That means pi over 4, which is 45 degrees, pi over 3, which is 60 degrees. So you have 105 degrees. 105 is easy to establish that it is the sum of the two. But if it's a little bit more difficult when it involves pi, then you can change it to degrees, make a decision, bring it back. All right. Now, what are we going to use? We are going to use this formula. Cosine of alpha plus beta is cosine alpha. That means cosine, remember, alpha is pi over 4 now. Beta is pi over 3. Are you with me? So cosine alpha, that means cosine of pi over 4. Cosine beta, that means cosine of pi over 3. Minus sine alpha, that means sine of pi over 4. Sine beta, that means sine of pi over 3. If you follow this question, you are getting into good shape, class, as what we are doing in this section. If you honestly understood what's happening here, you're fine. Okay, you have nothing to worry about.
This
Okay,
makes
I want
much more
you.
sense.
Okay, good, good. That's it. That's it. Now, the other one will prove it will make sense to you when you see more examples here. I guarantee you that.
Basically where we
All right.
left off in trigonometry.
So now, all of them are common arcs. Just plug in. Okay, all you plug and you're done. So what is cosine of pi over 4? Of course, the assumption is now you know it. You can put it in fast. So it's square root of 2 over 2. Cosine of pi over 2 is 1/2. Sine of pi over 4 is square root of 2 over 2. And sine of pi over 3, pi over 3 is square root of 3 over 2. You put it in there. All of them have the same denominator 4. So the top becomes square root of 2 minus square root of 6. Now, I hope going from here to here is not a problem. Going from here to here, however, requires knowing all the common arcs. Okay. All right, let's move on, class. So you see that this thing actually can go very fast. So I'm going to go to the next example. Any questions?
No.
Now, can we think of, everybody, can we think of two numbers that they give us 15 degrees? Either we add them up or subtract or however that comes to mind, but both of them should be common arcs. So what comes to your mind? Can you tell me?
45 minus 30.
Beautiful. You're practically done. Now, are you going to use the first or the second formula?
Second.
Okay, very good. So we're going to write cosine alpha, cosine beta. That means cosine of 45, cosine of 30. Okay. Plus sine alpha, sine beta, sine 45, sine 30. Do we see this, everyone?
Yeah.
Yes.
Good. Now, I'm assuming you know the common arcs. These are the common arcs, everybody. So you add them up. Square root of 2 times square root of 3 is square root of 6, plus square root of 2 times 1 is square root of 2, and the denominator is 4 for both of them. Okay. What I want you to notice, it might be helpful in the future, that pi over 12 is the same as 15 degrees. Okay, class? Pi over 12 is the same as 15 degrees. That is also helpful. So, what did we do? We learned about the sum and difference formulas for cosine, and we could come up with a couple of easy questions to deal with here. For example, cosine of 15 degrees. That sounds good, everybody?
Yes.
Excellent. All right. We are going to move on to the next one. I hope everybody is fine with that. So here's the next one. We want to establish the same thing for sine. So take a look at the top right. These are the formulas we proved for cosine. Is that right? Now look at the bottom. These are the formulas for sine. We want to prove those, okay? And we are going to prove those. If you follow what the proof is for those, and again, since we have already established the top ones, goes very fast. If you can see that, you will be comfortable with the proof of cosine that we did also. I guarantee you that. All right. So here we go. Cosine of pi over 2 minus theta is sine theta. Sine of pi over 2 minus theta is cosine theta. There are two ways to prove it. One way is to graph. Look at the one that is in purple. You can graph and observe. But more importantly, we can do this analytically, algebraically, and that's what we are going to do right now. Now, before we move on, okay, you have had trigonometry, and if you recall, in the case of a right triangle, okay, a right triangle, okay, sine of one angle was equal to the cosine of the other. Do you remember that, class? That means, you know, they were what? Complementary angles. That means they would add up to 90 degrees or a pi over 2. I'm hoping you guys remember that. So cosine of pi over 2 minus theta is sine theta. Sine of pi over 2 minus theta is cosine theta. Tan of pi over 2 minus theta is cotangent theta. Those are called cofunctions, okay? So when their angles add up to pi over 2 or 90 degrees, then their trigonometric functions are equal. I hope you remember this stuff. In any event, so what comes next? Let's look at the proof for the first one. How would you write cosine of pi over 2 minus theta? You would use the second formula in blue, okay? And you would write cosine of pi over 2 cosine theta, okay, plus sine of pi over 2 sine theta. This is the second formula in blue. Is that right, everybody? Yes or no?
Yes.
Yes.
All right. Can you tell me what's cosine of pi over 2? Okay, I hope you see what's going on here. This is as basic as it gets, and if you're uncomfortable with common arcs, it's going to be very hard to move on. Cosine
0.
0, sine 1, and we just proved cosine of pi over 2 minus theta is sine theta. Okay, you really don't have time to think about cosine of pi over 2 or sine of pi over 2. You just don't. You should know them. All right, I'm going to move on. We're going to see how we prove the next one. It is so easy that actually becomes confusing. So pay attention to that and see how that goes before we prove the second part. Is everybody okay with that? All right. The second part says, what is sine of pi over 2 minus theta? Okay, so that's what we are going to establish, okay? So sine of pi over 2 minus theta, we can write it's the same as cosine of pi over 2 minus pi over 2 minus theta. Okay, I'm telling you, I hope it is not confusing. The idea is we are discussing that. Let's just see this. I want to make sure everybody can see that. You see this one, everybody? Yes? We are using this formula, okay, to establish what's happening. Now, I want you to look at the right side. Sine of theta, okay? This is the right side. This is sine of theta, yes?
Mm-hmm.
And look at the left side. Is pi over 2 minus that. So I want you to think of theta. Okay, let me use a different. I want you to think of theta as something else. Even I'm going to put a question mark. Something else. Anything that theta is, that means you are going to replace it here. Am I correct, everybody? For example, if I said sine of alpha, that means cosine of pi over 2 minus alpha. Yes or no? If I said sine of x, then would be cosine of pi over 2 minus x. Yes? So we are looking at the right side, sine of theta. So instead of theta, I want you to think about this class as x. Think about this as x. Are you with me? Don't think of it as pi over 2 minus theta. Think of it as x. So therefore, this is cosine of pi over 2 minus x. I hope you're following there. And now, pi over 2 minus pi over 2 plus theta, and that is the proof. Again, I think this is extremely simple yet confusing, and understand that, okay? So now that we have established the relationship between co-functions meaning when the angles add up to pi over 2, okay? Then we're going to use that to go over the proof for the sine. Now, everybody okay with that? Are we ready for the next one?
Yeah.
We want to prove the sine, okay? And we remember from the previous page, on the right side, we have this. So if I want sine of alpha plus beta, so I want to establish the first one in purple, okay? So sine of alpha plus beta, I want you to think about this, everybody. Take a look at this formula. Take a look at this formula. Instead of theta, class, instead of theta, I'm going to use alpha plus beta. Do you see that if I use alpha plus beta, then this one should be alpha plus beta, yes or no?
Yeah.
And that's what we have here. So sine of, so you're looking at the right side of the equation at the top right. The right side is sine theta. Sine theta. This is cosine of pi over 2 minus theta. Do you see that, everybody? Okay. Now we're going to, okay, imagine alpha plus beta is theta. That's all I'm saying. Okay.
Yeah.
So with
yeah,
that,
I see it now.
good.
Okay.
Now, with that being the case, we are going to put these two together. We get pi over 2 minus alpha, okay? And then we have beta, okay? Now we established, okay, so we are going to expand this cosine of pi over 2, cosine of pi over 2 minus alpha, cosine beta, plus sine pi over 2 minus alpha, sine beta, okay? And then we replace cosine pi over 2 minus alpha with sine alpha. Again, we are reusing and reusing and reusing the top formulas. So this becomes sine alpha. Okay. And this becomes cosine alpha. Oh boy, this is acting up.
Professor, shouldn't it be plus cosine B?
Cosine beta. You talk about this is sine alpha,
Above.
cosine beta plus cosine alpha sine beta. This one
The line
is
above.
cosine. This one.
The one right below. There we go. The one in the middle. Yeah. Can you explain that middle line?
Over here.
Yes.
Is that what you're asking?
Yes.
Okay. So we are establishing cosine of alpha plus beta. We are using the fact that cosine of alpha plus beta is what? Cosine alpha, cosine beta. Okay. So cosine, let me just write it here. Cosine of alpha plus beta equals cosine alpha cosine beta minus sine alpha sine beta. Okay.
Also, you're re-putting the formula again.
Yes.
Okay. I'm sorry. I didn't catch that.
Okay.
I
No problem.
was multiplying for some reason. I don't know why, but okay.
No, and then again, we keep on repeating the same formulas. And then we end up with sine of alpha minus, we use the same trick because we established the first one, everybody. Now for this one, we put minus beta is the same as plus minus beta. So we can use the first formula. And anywhere we see beta, we change it to minus beta to do the math, okay? And so that takes care of that. In any event, I highly recommend you go over that, after, we're done here, because I want to make sure that you, but by the way, this is, my apologies, this is mine, as I thought, everything else is correct. That is supposed to be a negative sign, okay? When we distribute the negative, I thought I put a negative sign there. Okay, everything else is correct, okay? And so if you choose minus beta and you replace it, you get sine alpha cosine of negative beta plus cosine alpha sine of negative beta. Now, again, what is cosine of negative beta? Cosine is an even function, which means cosine of negative beta is the same as cosine beta. But sine is not. Sine is negative. Okay, because it's an odd function. So I hope you see all those fundamental identities that we discussed and how important they become now, okay? To remember all those identities, and therefore we can easily establish the new identities we want here. So you really need to use, to remember Pythagorean identities, you really need to remember the reciprocal ones, and of course, even and odd. Even and odd, it is extremely important. All right, let's quickly put this to a good use, okay, as far as evaluation of some other angles that are not common arcs. For example, we want to find the exact value of sine 19 pi over 12. And again, it's not a common arc, but it's a sum of common arcs. Again, if I don't know what it is, I can always change it to degrees, because sometimes it's easier to deal with degrees. This is your choice. However, I'm showing you that 19 pi is the sum of 16 pi and 3 pi. Both of them divided by 12. It results in sine of 4 pi over 3 and pi over 4, both of which are common arcs. Both are common arcs. So establishing that this is the same as this If it's not easy, go to degrees, everybody. Go to degrees, okay? It makes it easier. By the way, when the denominator is the same as the, see, for example, just to understand 4 pi over 3, I want to make sure you understand which quadrant. If it were 3 pi over 3, that means 180 degrees. That means pi. That means it's a straight angle. But because the numerator is 4 pi, then it puts you in the third quadrant. So you should be able to recognize that. Now we are going to use the top formula, the first one, sine of alpha plus beta. So this is sine alpha, that means sine of 4 pi over 3, cosine beta, that means cosine of pi over 4, plus cosine alpha sine beta. That's what we get. Let's discuss 4 pi over 3. I hope everybody can see pi over 3 is your reference arc, which means we know pi over 3, we know the answer, we just have to figure out positive or negative. So this is the same as sine of pi over 3. Sine of pi over 3 is square root of 3 over 2. In the third quadrant, sine is positive or negative, class?
Negative.
Third quadrant, negative. So that takes care of the business, okay? Same thing for cosine in the third quadrant is negative. So it becomes a negative square root of 3 over 2 times square root of 2 over 2 plus negative 1/2 times square root of 2 over 2. Simple. And so now the denominator is 4 for both of them. Just add up the top as we've done it before. Negative square root of 6 minus square root of 2. Sounds good, everybody? Boy, it took a long time to get this far. I didn't think so, but that's life. Let's move on. We have a lot to do, class.
Okay.
Any questions?
No.
All right. We want to use the sum and difference formula to see what it is. So to establish that, it should be very easy. I want you to look at part A. Again, you have the questions available. So just, we want to, you know, just brainstorm, making sure we are comfortable with that. Number one, look at the top formulas on the right, the 4 formulas, and establish it looks like which one. Okay? Number 1, number 2, number 3, number 4, which one?
A looks like number 3.
It looks like number 3. Okay? Okay. So how would we rewrite this, everybody? In other words, looks like the right-hand side of number 3. Do we see that, everybody? Now, the answer would be the left-hand side. Cosine of what?
Of 40 degrees plus 80 degrees.
Sounds good, which is 120 degrees.
Mm-hmm.
Very good.
Okay.
What is cosine of 120, everybody? Okay. It's the same as cosine of...
3?
Yeah, pi over 3 or 60 degrees. In the second quadrant, cosine, positive or negative?
Negative.
So negative 1/2. Okay. Now I'm gonna stop at this point. I want everybody to figure out part B and finish it from A to Z. You have 1 minute, go. Okay. Anybody want to share with us the answer?
80 minus 20.
Okay, you're right, but what is that? What 80 minus 20?
Option number
What
3.
trigonometric function are you using?
Sine.
Beautiful. That's what I'm looking for. And sine 60, everybody knows the square root of 3 over 2. So I hope you see, all you have to do, recognize it's sine of 60, the rest is easy. That sounds good? Everybody? All
Yeah.
right, we're going to move on. All right. Here's the next example. We know sine alpha, we know sine beta, and we know the quadrant they belong to. And we want to find cosine alpha, cosine beta, and the other two. So let's go with cosine alpha and cosine beta. This is like the old stuff, it's fairly fast, okay? So let's quickly do that. There are different ways of approaching it. You can say sine is 4 over 5 or y over r, okay? So y is 4, r is 5. And in quadrant 2 class, quadrant 2, cosine is positive or negative?
Negative.
Very good. So you can figure out the x, and the answer is negative 3 over 5. Now, I went over this fast because we've done this class. Is this the only way to do it? No. You can use the identity. What is the identity? Sine squared plus cosine squared equals 1. So you could use and of course figure out the sign, positive or negative. So which one is easier? I have no idea. You make a decision. There are two ways to do that. We just did it with the help of a circle, or you can do it with the identity, sine squared plus cosine squared equals 1. So that one is done. Agree? So this would be if you were to do it by the identity. Okay, I'm showing you both just because I want you to be exposed to that. Do you have to do both methods? Absolutely not. Absolutely not, class. Okay. Now what about sine beta? Okay, sine beta is given, and we want cosine beta. You have a choice. You do the same thing or the identity. One of the methods will give you the answer. Now the question is though, which quadrant is that, class? Quadrant 3, yes? In quadrant 3, cosine, positive or negative?
Negative.
Negative.
So you establish it, you plug it in, and you choose a negative one. So I'm using the identity sine squared plus cosine squared equals 1. I have sine, I figure out the cosine. And as far as positive and negative, I have to pay attention to the quadrant. Is everybody okay with this? Okay. And so what happens now? We get to part C. What is cosine of alpha plus beta? Okay, so sine is, all of this is quadrant. So this is the formula that you have and you know. This is the formula that you have and you know. Okay. So just plug in. At this point, you don't have to worry about the sign. The sign will work out accordingly. Okay, everybody? Which means you just plug in the numbers you came up with. Take a look at the numbers you came up with. 25 is the denominator. When you multiply it, you get positive 11 square root of 5. I hope everybody can do the math. Part D, you plug in. You don't have to worry about the sign. The sign will take care of itself, okay? Because you're using an identity. And the answer is 2 square root of 5 over 25. Is everybody following this class? Is there any questions? All right. I'm going to go to the next one. Again, how do we find cosine alpha and cosine beta? The fastest way, sine squared plus cosine squared is 1. How do you find the other two? You have formulas, plug in. Okay, it may be a little bit tedious putting the numbers, all of them together, but I hope you see how easy it is. Again, A and B, sine squared plus cosine squared is 1. You're done. C and D, the formulas we just established. Okay, everybody? I'm going to move on. All right, cosine of power 2 plus theta, we want to prove is equal to negative sine theta. So we're going to start with the left-hand side. Can you tell me how you would write the left-hand side? How would you write cosine of power 2 plus theta? Let me hear you. Using one of the four formulas that you see. What do we get? Fast. Let me hear you. This is cosine of alpha plus beta. So cosine pi over 2 plus cosine pi over 2 cosine theta minus sine pi over 2 sine theta. Okay. So what is cosine pi over 2? 0. What is sine pi over 2? 1. So the answer is negative sine theta. Okay.
Okay.
Does that make sense, everybody?
Yeah.
Let's look at this one. Cosine of pi plus theta, we want to prove is negative cosine theta. We start with the left-hand side, and we use the same identity, cosine of alpha plus beta. So cosine pi cosine theta minus sine pi sine theta. What is cosine pi, class? Anyone?
1.
Negative 1. What is sine pi?
0.
And you're done. Okay, class? All right. I want to go over the next page quickly. It shouldn't take more than a minute. The proof is there, but it's important for you to see that so we can move on. I am hoping that we finish this, and there are 2 more sections we need to finish to get you ready for the exam. Before we do so, any questions on this page? Okay, I'm assuming we are done. So here's the next page. It shouldn't take more than a minute, and then we take a few minutes of break. We want to prove the green formulas. Tan of alpha plus beta is tan alpha plus tan beta over 1 minus tan alpha tan beta. And the other one, you switch the sign. So in order to prove that, we know tangent is sine over cosine. So we start with sine over cosine. That works for everybody so far? Now you put the first formula, sine of alpha plus beta at top, and the third formula, cosine of alpha plus beta at the bottom. Okay. Now, we want to establish the right side. If you look at the green, so we have to have a technique, a trick, if you will. Okay. So here's an easy technique that can show you what you need to do. If you look at this one, everybody, let me use a different color. Let me use a different color. Everybody can see I have number 1 here, yes or no? Everybody can see the number 1, yes or no?
Yes.
So that means we are hoping this would change to number 1. Do you agree? I take it as yes. So I hope you see that we want that one to be 1. So how do you make it 1? Well, not a problem. Divide everything by cosine alpha, cosine beta. Divide everything by cosine alpha, cosine beta. Divide everything by cosine alpha, cosine beta. Okay? So now, they cancel each other. What is this, everybody?
Tan.
Tangent alpha.
Tangent.
Very good. These two cancel each other. What is this one?
Tangent also.
Very good. Tangent of beta. This whole thing changes to number 1, doesn't it?
Yeah.
Minus this one
Tan to the tan square.
times this one. No, tan alpha, tan beta. Believe it or not, this is the proof class. Now, what you want to do on your own, prove this one in the same manner. We're going to take a break. And the trick is very simple. Replace, okay, the beta in the first one with negative beta. Okay? If you replace this beta with negative beta, you should prove the second one. See if you can do that. If you can do it, you can follow what we have been doing. We have a lot to do. Class is 7:03. We come back at 7:10. I'm going to pause the recording. Our class, as I mentioned, we have a lot to do. So let's quickly go over the proof of this one again to refresh your memory how these things are done using the bottom formula. Okay, so tan of 2 pi minus theta, we are going to write the formula at the bottom. Okay, tan alpha plus tan beta, so that becomes tan of 2 pi minus tan of theta over 1 plus tan 1 minus tan alpha tan beta. Okay, in this case we use a negative, and I'm going to show you the formula to refresh your memory. Okay, if you recall, for tan of alpha minus beta, we have tan alpha minus tan beta. Okay, class, over 1 plus tan alpha tan beta. That's the formula we are using. Okay, I want to make sure that everybody is comfortable with that. So with that being the case, well, all we have to do is just simplify the rest. And how do we simplify the rest? We just plug in. We know tan of 2 pi is 0. Okay. Sounds good, everybody? Any questions? All right. That's a very straightforward question. Let's look at one more example like this. We are almost ready to move on. A couple more example questions. Questions from this section, and then we are ready to move on. Okay, we want to prove this identity. We start from one side. For example, in this case, the left side, cosine of alpha minus beta over sine alpha sine beta. That's what we are going to start with. Cosine of alpha minus beta uses the fourth formula. Okay, cosine alpha cosine beta plus sine alpha sine beta, and we write the bottom. Okay, and this is a very straightforward question. All you have to do, make up two fractions. Everybody understands what I'm saying here, right? Make up two fractions. What is this? What is this? And this whole thing is 1. So that's a proof that is the right side. Sounds good, everybody? All right, I want you to do the next one on your own, okay? So we are going to skip the next one. I want to look at this one because it's more interesting. The next one, you can do it on your own. So the left side, cosine of alpha plus beta, cosine of alpha plus beta over cosine of alpha minus beta is equal to the right-hand side. So the left-hand side uses the formulas in blue. We are going to write the left-hand side as follows. Okay. Now again, when you come this far, this is important for you to notice. It may be very difficult, class, to see how we arrive at the answer. So sometimes you really have to look at what you want to get to see the answer. What is it that you want to get to? You're hoping to get to number 1 as your first term for the top and the bottom. How do you get there? Well, what if we could divide by this, the top and the bottom? We do get to the 1 if we do that. As you can see, this is 1, this is 1. Then what do you have? Sine over cosine, sine over cosine, sine over cosine, sine over cosine. All of them are tangent, class. Do we see that, everybody? Is there any questions? I'm going to get the last question in a moment, but we are trying to learn the tricks. Sometimes it's very straightforward. Sometimes we got to come up with the tricks to do the job. All right. Here's the next example. The last one is, and again, you know, there are a few more that you're more than welcome to look into on your own. Is everybody done here?
Yes.
Thank you. Now, we want to find the exact value. What is really important for all of us to realize when we are looking at cosine inverse or sine inverse, we are dealing with an arc. So what is cosine inverse of 2/3? I don't know. I'm going to call it alpha. What about sine inverse of -3/4? I don't know. I'm going to call it beta. Anything you want. So in essence, you want cosine of alpha plus beta. That's what you're looking for, everybody. So you start with the first one and you write cosine of alpha is 2/3 and sine of beta is -3/4. Okay. Now, so cosine alpha is positive and it's between 0 and power 2. Why is that? Because the inverse function for cosine, remember, it goes from 0 to pi. Everybody remembers that. For sine, goes from negative power 2 to power 2. Therefore, this must be in the fourth quadrant, okay? And so you are going to calculate cosine of alpha plus beta using the third formula. So you need cosine alpha, you have it. You need to find cosine beta, you don't have it, and the rest of them. So you can use Pythagorean identities, you can use the circle, it is absolutely up to you. So if cosine, okay, so sine is positive, okay, and cosine beta is positive, sine of alpha, okay. Everybody understands why sine of alpha is positive, right? Because alpha is in the first quadrant. Why cosine is positive in the fourth quadrant, cosine is positive, okay, class? So sine squared plus cosine squared equals 1. Sine is square root of 1 minus cosine squared. So before you go, it's important to understand why this is the case, okay? okay, a quadrant. And so you work it out, you get square root of 5 over 3. Same formula, sine squared plus cosine squared is used for beta, and you get square root of 7 over 4. So these two should happen fairly fast. So what is cosine of alpha plus beta? Is cosine alpha cosine beta minus sine alpha sine beta. Now you plug in those numbers you found. So you have 2 times square root of 7 plus 3 times square root of 5 over 12. Over 12. All right, class. I'm going to go to the next page. In fact, the next section. Why don't we just do this? Okay, I'm going to stop the share and this is 7.6. So we are looking at section 7.6 and we're going to share. So everybody is looking at section 7.6, double angle and half angle formulas. And so let's continue. We just established some formulas, okay, in section 7.5. And here's the synopsis of 7.6. There are a lot of formulas, class. Believe me, I understand. Okay. Double angle, half angle formulas, you name it. Okay. So I want to go over some of the proofs quickly. And so at the very least, we have an idea how we arrive at it. And then we use them. For example, why is it that sine 2 alpha is 2 sine alpha cosine alpha? Or cosine 2 alpha is cosine squared alpha minus sine squared alpha. It has also 2 more ways of looking at it. This is the summary of everything that you need. I think everything is on this page, okay? But let's quickly establish the proof. Okay. All right. To establish the proof, first look at the top right. These are the formulas from the previous section. Now we want to prove sine of 2 alpha is 2 sine alpha cosine alpha. So how do we do that? It's very simple. Look at the very first formula on the right, sine of alpha plus beta. We're going to use sine of alpha plus alpha. How about that? Is everybody following that? If you use sine of alpha plus alpha, that is sine of 2 alpha. Okay, so we are using this one, everybody. And anywhere you see beta, you also use alpha. So what do you have? 2 sine alpha, cosine alpha, believe it or not. It goes that simple, okay? What do you think we do for cosine of 2 alpha? We use the same thing, cosine of alpha plus beta, and we write it as cosine of alpha plus alpha. Do you see that, everybody? All of this is posted. I want you to see the concept, okay? So cosine alpha minus sine alpha, and that is cosine squared minus sine squared. Now, sine 2 alpha has one answer, cosine 2 alpha has 2 answers. My apologies, 3 answers. This one we established. Now, if we replace the cosine squared with 1 minus sine squared. I hope you see that it gives you 1 minus sine squared or 1 minus 2 sine squared. If you change sine squared with 1 minus cosine squared, because of the negative sign, it gives you 2 cosine squared minus 1. So I hope you see that why we have 3 answers in the case of a cosine to alpha and how we arrive at those answers. Okay, those are very simple, class. So you can use this last formula to solve for sine squared alpha. I hope you see how you can do that. Okay, you move the 1 and you divide by negative 2. If you use this formula, the second formula, and if you move the negative 1 and then divide by 2, you get cosine squared alpha. Okay. How do you think we get tan squared alpha? Tan squared alpha is sine squared over cosine squared. So if you divide the blue by the green one, it gives you tan squared alpha. Is everybody following that? Is everybody following the proof? You know that you may not remember the proof, but if you try to remember it, it'll help you remember the formulas. Because you can use the proofs to establish the formulas very fast. Okay, class? Now, this gives rise to the idea of half angles. What if you change 2 alpha to alpha? Then you have to change the alpha to half of that, okay? If you change this one to alpha, then you must change this one to alpha over 2. And that's the case for tangent, okay, cosine, and sine, okay? So tan squared alpha is 1 minus cosine to alpha over 1 plus cosine to alpha. So tan squared of alpha over 2 is 1 minus cosine alpha over 1 plus cosine alpha. And the rest of it, you know, follows. You just change the 2 alpha to alpha, and you change the alpha to half of that. All right. Again, for now, you have the formulas available to you. You can use them. Ultimately, you got to get very comfortable with them. So I hope everybody can see how we establish these new formulas, okay? So we established sine to alpha, we established cosine to alpha, we established sine squared, cosine squared, and tan squared for alpha as well as alpha over 2. We are looking at a lot of proofs here. These are the pages you really want to go over and get comfortable with, class, okay? All right. From the previous page, we have this. We have tan of alpha plus beta. We have cosine squared of alpha over 2, sine squared of alpha over 2, sine squared of tan squared of alpha over 2. How do we prove tan of 2 alpha? How do we get to that? Well, just the same thing as sine and cosine. Over here, class, put another alpha and the beta to alpha. Notice what happens. It becomes tan of alpha plus tan of alpha minus tan alpha times tan alpha. So this is what? 2 tan alpha over 1 minus tan alpha squared. Okay? I hope you can see how this thing is working, class. Now, look at the other three formulas. In blue, green, and purple. What if I want to get to cosine of alpha over 2? And what if I want sine of alpha over 2 or tan of alpha over 2? Just take a root. I hope you see the root will give you the answer, the square root. Okay? And of course, you make a decision as to the quadrant, what the number is. So for tan alpha over 2, you can use sine over cosine, and it can be established in this manner. I want you to know that, class. But here's the synopsis of the half-angle formulas. Here's the synopsis of half-angle formulas, okay? And again, how do we come up with the plus minus sign? Quadrant, quadrant, quadrant. I can't emphasize this enough. So this page, again, we do have the proof, everybody. I hope you can see that. And you do need to spend a little bit of time getting comfortable with this stuff, okay? All right. Let's, as I mentioned, the sign, positive and negative, comes from the quadrant, okay, class? So this was the sign, okay? So there are more formulas that we can prove. Sine squared of alpha over 2 from the previous page, if you recall, was 1 minus cosine alpha divided by 2, okay? We can multiply both sides by 2. So multiply both sides by 2. Gives you this equation. Okay. And there are other formulas that for tan alpha, you have a number of formulas. But honestly, let me go back to the previous page and tell you the easy way out for that. You know sine and cosine, right, class? Take a look at those two. You don't have to worry about tangent. Tangent is the ratio. When you find sine of alpha over 2 and cosine of alpha over 2, you really don't have to go through the process of finding tangent of alpha over 2. Divide the two and you're done. Divide the two and you're done, class. Okay? Sounds good? So I'm establishing other formulas for you, but remember, if you are calculating, this is the fastest way. Calculate sine and cosine only. And then the tangent, the rest of them. All the trigonometric functions, you can find them in no time, okay? So tangent would be sine over cosine, and the rest of them are the reciprocals. So that should go very fast. All you have to establish is sine and cosine. The rest happen in no time. So in any event, so I'm explaining how the proof comes. But let's look at a couple of examples here, see how we put this together. And these things that we discussed. So given that sine is 3 over 5 and pi over 2 to pi, okay, which means quadrant 2. We want to come up with sine 2 theta and cosine 2 theta. Okay, so in order to come up with that, look at sine 2 theta. Sine 2 theta means the answer is 2 sine theta cosine theta. We have sine, we need to find cosine. So we use the Pythagorean identity. So we have sine, we get to cosine. Okay. Pythagorean identity gives us that. And we are going to use the negative. Can anybody tell me why the negative?
You said second quadrant.
That's it. Look at it. This one, class, this one. This one says second quadrant. It tells us theta is between pi over 2 and pi. We really don't have to think hard. It is given to us. So again, we are using Pythagorean identity to get to cosine. Now we just plug in 2 sine theta cosine theta is the answer. Is everybody okay with that, class? So I hope you see we had some formulas. We went over the proof of sum. If you can follow it, if you can follow the formulas, it helps you memorize. Okay, but aside from that, it's very straightforward, class. You see questions we look at are fairly nice and easy. Now, what about part B? Part B says, okay, cosine 2 theta. You have the formula, cosine squared theta minus sine squared theta. You have each one, plug it in. So the first one is 16 over 25 minus 9 over 25. So 16 minus 9 is 7 over 25. Okay, 7 over 25. Very simple. As long as we got the formulas, we can easily handle them. Okay, class? I hope this example really puts this into a good perspective. It's really not that difficult. Sounds good, everybody? I want to go to the next example. Good. We established this. We're not going to, this we have already gone over that. You can go back to the notes. So this is, okay, this sadly doesn't have, oh my God, the order is not what I had in mind. Okay. Well, at the very least, it's worth looking at it, although the animation is not proper. But at least let's just quickly explain that since everything is here. So let's start with the first one. The first one, part A, says cosine theta is 2 minus 2 sine squared theta. Okay. And let's calculate the theta. And theta is between 0 and 2 pi. Okay. So we can establish what's going on here. Okay. So 2 minus 2 sine squared theta. Okay. If we bring it to the other side, what is cosine 2 theta? Okay. We can write cosine 2 theta. Remember cosine, let me write all of them, see if you remember this. Cosine 2 theta is what? Cosine squared theta minus sine squared theta. It's also equal to 2 cosine squared plus this one. 2 cosine squared theta minus 1. It is also equal to 1 minus 2 sine squared theta. Everybody remembers that? Okay, so or at least we've seen this. Okay, 1 minus 2 sine squared theta. Now Which one are we going to use? Look at the right side. Right side is what?
The
Is
third
all sine, right? It involves sines, right? So you change the cosine to theta also to something that involves sines. Do you follow what I'm saying, class? So I'm going to replace the cosine to theta with what? 1 minus 2 sine squared theta. Does that make sense? And therefore, you get to this. You drop the 2 sine squared from both sides. That's an equality. Do you see that, class? That's an equality. Both sides have 2 sine squared negative. So 1 is equal to 2. Well, that can't be, so there is no solution. Is everybody following that?
Yeah.
So, again, it's important for you to see which one you're going to use and why. Why are we using 1 minus 2 sine squared theta? Because the right side involves sine squared. Let's do it that way. Okay? Sounds good, everybody?
Yeah.
All right. Let's look at the next one. Sadly, again, I don't have it in a proper format, which was animation, but at the very least, you can see how these things go. So let's quickly do that. Sine 2 theta plus cosine 2 theta equal to 0. Generally speaking, if you have sine and cosine, okay, you can take them to different sides and divide by cosine, change them to tangent. I want you to know that, okay? So if you take the cosine 2 theta to the other side and this divide both sides by cosine 2 theta, this becomes tangent and this becomes just a constant, -1. So tangent 2 theta is equal to -1. All right. So what is the answer for 2 theta? Okay. If the question was from 0 to 2 pi, okay, you could establish with n pi and then divide by 2. But it's asking for a general solution. So 2 theta is 3 pi over 4, because remember, -1, which means what? We are in the second quadrant, okay, or in the fourth quadrant. And then when you add n pi, I want you to know that the moment you add n pi, if you choose n equals 1, it gives you the other one in the fourth quadrant, okay? And then if you divide by 2, you get 3 pi over 8 plus n pi over 2. What I want to quickly go over, what if we had only, if we were interested in from 0 to 2 pi, how we would get to the answer? That I want to establish, because we had this situation last time, some students were uncomfortable. Because we want the general solution, you're done here. I want you to know that, okay? And if you go with that, then you can replace the n with different numbers, okay? Such as 0, 1, 2, 3, and come up with the answer. However, the way I explained it last time, I want everybody to see what happens here, is that 2 theta is either 3 pi over 4 in, it looks like 5, but it's 3 pi over 4 plus. Okay, or 7 pi over 4. Okay, now in order to establish theta, you have to add n pi and then divide by 2. When you divide this one by 2, you get theta is 3 pi over 8, everybody, plus n pi divided by 2. This is 1. This will give you theta equals 7 pi over 8 plus n pi over 2. In both cases, and I'm not going to finish it up, choose n equals 0, come up with an answer. Choose n equals 1, come up with an answer. You have total of 4 answers. You have total of 4 answers. Okay, class? Any questions? All right, I'm going to move on. Here's the next example. We want to write an expression for cosine to the power of 4. Such that it doesn't involve any powers. And we remember this one. So first we're going to write cosine squared to the second power. And we replace the cosine squared with what we established at the bottom. Now, whether it's alpha, beta, theta, it makes no difference. Now, we're going to raise this to the second power. I hope you see that the 2 in the denominator, that means 1/4. When you square the rest of it, this is what you get. This is algebra, class. This is algebra. So we apply the 1/4. Remember what we want. No powers. So everything is good except this one, because it has a power of 2. And so what do?
Do we replace it again with the cosine square of alpha?
Beautiful, beautiful, beautiful. So when we do it again, it looks like this. The first piece and the second piece do not change. This piece changes to 1/4 times. Now, cosine squared of 2 theta. Okay, basically you change the alpha here to 2 theta, which gives you 4 theta. Now we are going to multiply by 1/4. Get 1/8. 1/8 times 1 is 1/8. 1/8 and 1/4, we can add them up. 3/8, the rest we just write them. Okay, sounds good.
Yeah.
So here's the next one we are going to look at. We want to solve this equation.
Harry, do you mind going back a couple of...
Sure.
Thank you.
My pleasure. Is everybody okay with the concept?
Yes.
All right. We are going to use the formulas that we have seen to see if we can simplify the left side. Can anybody see the left side using one of those 2 formulas in blue? Look at the formulas in blue. Can we use any of them to change the left side of this equation?
Yes. We can put use the first one on the top.
This is alpha, this is beta, right? This is alpha, this is beta, right? So
Yeah.
it's alpha plus beta, isn't it? Isn't it alpha plus beta, everybody?
Yes.
So you're practically done. Cosine 3 theta is 1/2, okay? That means 3 theta is pi over 3. Okay. In the first quadrant, cosine is positive, and also in which quadrant, class? Is one more quadrant. Cosine is positive in the first, and
The fourth.
Or
therefore is 5 pi over 3. We add 2k pi. And by the way, when they say solve and they don't say from 0 to 2 pi, that means all solutions. You divide by 3. This is the answer. Now, class, if the question, I can't emphasize this enough. Okay, I'm going to add this. If the question was asking from 0 to 2 pi, then you would choose n equals 0, n equals 1, n equals 2, and you're done. Okay, y all the way to 2 because it's cosine of 3 theta. Okay, class? All right, let's move on. All right. Actually, the next one is fairly simple, class. I want to see if I can move on. You can. It's really simple. You can figure it out on your own. I want to go to the following. I'm hoping we can finish this so we have an exam for Sunday. Otherwise, I've got to give you the exam next Tuesday. So we're going to finish this tonight. So we're going to stick around for as long as it takes. Are we ready for that, class?
yes.
Yes.
Okay, let's do that. This one you can read it on your own. It's very simple, honestly. Okay, how do we use the half angle? Okay, let's start with the simple case of a 22.5 because we recognize 22.5 is half of a common arc. Which arc is that? 45 degrees, right? So you can say this is sine of 45 divided by 2. And so you want the sine. So you're going to use this formula. Are you going to use positive or negative, class? Which one? Can anybody tell me? Positive or negative? Which one and what? Positive or negative? Which one? 22.5 degrees is in the first quadrant. Everything is positive.
Positive.
Okay, so 1 minus cosine of 45 degrees, which is square root of 2 over 2. If you multiply the top and the bottom by 2, you get 2 minus square root of 2 over 4. The 4 comes out, and this is your answer. Okay. Is everybody following there? What about 5 pi over 12? I hope you realize 5 pi over 6 is a common arc. And so it's 5 pi over 6 over 2, and we are going to use the cosine. Okay? Now, before we move on, class 5 pi over 2, which quadrant is that? Because we want to establish positive or negative before we move on. Which quadrant? Okay, class, remember, if it was, it's the first quadrant, okay? Because if it was 6 pi over 12 would be pi over 2. If the first quadrant is positive, you plug it in. Okay. Now, cosine of 5 pi over 6 is negative square root of 3 over 2 because it belongs to the second quadrant. Multiply the top and the bottom by 2. Okay, so you're multiplying by 2, okay? And so you end up with 4 in the denominator, comes out as 2. All right, 7 and 8 are the same class. So I'm going to spend a couple of minutes on number 8. 7 and 8. I put a lot of examples for you here. 7 and 8 are the same. We're going to look at number 8 for a few minutes. We're not going to go over the whole thing because, again, it works out in the same manner as this one. So before I go over there, is everybody done? Is everybody okay with that? Okay. The next section actually is fairly fast, so you don't have to worry about that. Okay, everything is posted here. You can look at it. All right. We want to find the exact values for sine of alpha over 2, cosine of alpha over 2, and tan of alpha over 2. Okay. So we want to find those. Okay. Where cosine alpha is negative, and we are in which quadrant? Between pi and 3 pi over 2. It's in the third quadrant, okay? And so alpha over 2 is between pi over 2 and 3 pi over 4, which is in the second quadrant. So we established the quadrant, everybody, okay? So what is sine of alpha over 2 when we use the formula in the second quadrant? And that is my point. The only reason I want you to pay attention to this question is that we established a quadrant. What is happening in the second quadrant? In the second quadrant, everything is negative except sine. So the purpose of this question is really for you to establish, okay, what am I using? Am I using plus or minus? Plus or minus? I'm using plus for sine, okay? So this is sine of alpha over 2. When you go through the process, it becomes square root of 4 over 5. Okay, and the rest is basic algebra. Okay, I don't worry about that. You can handle it. What about cosine? Well, we know cosine is negative. That's the thing you want to be careful of. Okay. So how do you find this? Let me explain how you find the cosine. 2 ways. Use cosine of alpha over 2, or sine squared plus cosine squared equals 1. So what I'm saying is that you don't have to use this formula, class. You can use this formula. You can use the Pythagorean identity that you're familiar with. But remember, whenever you're done, you have to choose the positive and negative accordingly. Is everybody following that? So if I want to find tangent, I'm not going to use that formula. I'm going to say sine over cosine. It's faster. Do you see that? It's faster. So you can always refer back to the formulas that you are familiar with. Okay, class. I want to finish this section. I want to look at an example which is different. Okay, so again, and understand sometimes students are not too comfortable with logs. That's why I'm going to use that. Before we get to the next page, I hope you understood the purpose of this example. Establishing the quadrant so you know in advance sine is positive or negative, cosine is positive or negative, okay? And really that's all you need. The tangent, you don't have to worry about it. It's sine over cosine. It will do the job. Is everybody following what I'm saying?
Yeah.
All right. Here's the next one, class. You really can start from the right-hand side to get to the left, or the left-hand side to get to the right. We want to establish the identity. If you want to go with the left-hand side, remember it's sine of 2 times 2 theta, and you use the double end. If you want to start from the right side, it is just as easy. Notice inside the parentheses, we are looking at the right-hand side. Inside the parentheses, 4 sine theta is in common. Do you see that, class? You can take out 4 sine theta from the parentheses. So if you take out 4 sine theta, you end up with 1 minus 2 sine squared. Is everybody okay with that? Use a different color. I want you to
So,
look at this part, only this part. Do you see this is 4 sine theta? Cosine theta? Do you see that, everybody?
yeah.
So that is 2 sine 2 theta. And this one is simply cosine 2 theta. So what you're looking at is 2 sine 2 theta, cosine 2 theta. You can literally think of it as alpha, okay? So you're looking at 2 sine alpha, cosine alpha, which is sine of 2 alpha. That means 4 theta. That means the left-hand side. Okay, everybody? I want to look at part B because it involves your favorite area, logs. It's something different. Before we do that, everybody understood part A. By the way, this one, if you look at this section at the end, I have a second method for that. We started with the right-hand side. We could also do it with the left-hand side. It's fairly simple. Here's part B. We want to establish that the natural log of cosine is half of ln of 1 plus cosine 2 theta minus ln 2. Clearly, the right-hand side seems to be more complicated. We are going to start with the right-hand side. To use the right-hand side, we are going to put these two together using the logarithmic formula, the quotient rule. I hope you remember the logarithmic formulas, okay? So here's the quotient rule. Everybody remembers that, yes? Okay, I hope you do. This is a natural log or logarithmic rules for the quotient rule. Log of A over B is log A minus log B, okay? That's the idea. And so 1/2 which is the coefficient can become an exponent. This is logarithmic rules, everybody. Logarithmic rules, everybody. Now 1 plus cosine 2 theta over 2 is cosine squared. Cosine squared to the power of 1/2 is simply cosine. And that is the left-hand side. Believe it or not, this is the proof. Okay? Now, I want to go to the last section. The last section won't take long. But for the next question, I just want to explain the first step. The rest of it you should be able to handle. Maybe we spend a minute going over that. It's worth going over that. Before we do that, I hope you understand a question like part B not only requires your knowledge of trigonometry, also it requires a knowledge of logs. And so I am giving you stuff that are a lot more complicated than some of the questions that you come across in your homework, because I really want you to see the deep, understanding of this. When you go to calculus, if you really follow what we are doing here, you won't have any problem. Here's the last question for this page. I want to spend a minute going over that. So we want to solve this. All right. If you recall, class, I told you cosine 2 theta has 3 ways of answering. If you go back to your notes, you can see that. Cosine 2 theta is cosine squared minus sine squared, 2 cosine squared minus 1, 1 minus 2 sine squared. Which one do we use? These are all involving cosine, so we use 2 cosine squared minus 1. This is the one we are going to use, because everything else is cosine. Now, we put it in descending order. If you have problem with that, you can change it to like, I don't know, 2x squared plus 5x plus 2. If you want, you can change it to 2x squared plus 5x plus 2 equals 0 and factor. You don't need to. When you factor, this is what you get. So cosine is either -1/2 or -2. Is everybody okay with this? Is there any question so far? All right. So the answers are 2 pi over 3 and 4 pi over 3. Can anybody tell me why? -1/2. Think of 1/2, and therefore your reference arc is pi over 3. Are you with me? Because it's negative, then it takes you to which quadrants? Okay, second and third. What about this one? There is no solutions because cosine can't be -2. I'm assuming we're done here. I want to go to the last section. Any questions, class? All right, we are not going to spend too much time on this, okay? But we will spend a little bit of time in case you don't have a lot of usage for this, but you do have some. I want to establish that. The product to sum and sum to product. So first and foremost, we covered a lot of stuff, okay? And you have, as you can see, there are a lot of identities that we got to get comfortable with, okay? So now, let's just hide this so it becomes easier to read and see everything. So this is the sum and difference formulas, okay? Double angles, okay? Everybody remembers them, okay? So there's really not much to worry about here. Now, here's the new section we want to discuss. Let's see how this thing works. The product to sum and sum to product. It's extremely simple, class. So you have a bunch of equations here, okay? So take a look at those equations. From those equations, we can establish the following. Okay, let's see how we do that. Let's see how it's done. Take a look at equation 1 and equation 2 for cosine. Everybody take a look at the equation 1 and 2 for cosine. Cosine alpha plus beta and cosine alpha minus beta. Okay. Now imagine we do equation 2 minus equation 1. And we divide it by 2. I hope you see that equation 2 minus equation 1 divided by 2 gives us the formula for sine alpha, sine beta. Can you see that, everybody? Equation 2 minus equation 1 and divided by 2. In other words, sine alpha, sine beta is half of cosine alpha minus cosine beta. minus cosine alpha plus beta. We established the first one. Okay. What if we add them up? What if we add them up and divide by 2? Class, equation 1 and 2, when we add up and we divide by 2, do you see it gives us cosine alpha, cosine beta is half of their sum? So we establish the second one. I hope you can see that. So equation 1 plus equation 2 divided by 2 gives us the second one. Equation 2 minus equation 1 divided by 2 gives us the first one. Now let's go with the sine. Now, sine of alpha plus beta and sine of alpha minus beta. Let's see what happens now. What if we add them up and we divide by 2? We get sine alpha cosine beta, and we get to the third one. And those are, believe it or not, the proof for the 3 equations. I'm going to look at a very simple example because we have just one question like this for the exam, and you can handle it. I think I put only one. The exam is not finalized yet. We'll discuss it in a moment. But believe it or not, this was the proof, and I hope you are okay with that, class. So sine alpha sine beta is half of cosine alpha minus beta minus cosine alpha plus beta. Cosine alpha cosine beta is half of cosine alpha minus beta plus cosine alpha plus beta. Sine alpha cosine beta is half of sine alpha plus beta plus sine alpha minus beta. And again, for now, you have the formulas, you can practice. Here's a very simple example. Here's a very simple example, and I'm going to show you how simple it is, because I bet you can answer this. Take a look, everybody. We are going to use the bottom piece, okay? We are going to use the bottom piece and apply it to these 3 questions. So let's talk about part A. Okay, let's give them numbers 1, 2, 3. Okay. Part A looks like number 1, 2, or 3, everybody. I can't hear you. Number 1,
3.
part A looks like 1, 2, or 3.
1.
Which one? Number 1. Why does it look like number 1? Because it's both of them sine. Sine 3 theta, sine 7 theta. Do you see that, everybody?
What?
Is everybody
what?
following?
You get quiet?
Yeah.
Class, mute your audio. So it looks like the first one. So you write the first one. 3 theta minus 7 theta is minus 4 theta, and plus becomes 10 theta. Okay. As you remember, cosine is an even function. Whether you have negative 4 theta or 4 theta makes no difference. You change it and you're done. It's that simple. Part B looks like number 1, number 2, or number 3. Which one?
2.
2.
Number 2. Everybody can see that, right? So 1/2 cosine of alpha minus beta, that means theta minus 5 theta. And then cosine of plus cosine of alpha plus beta, that means theta plus 5 theta. And you just rewrite it. So theta minus 5 theta is negative 4 theta. And we're going to replace it with 4 theta. And we're done. So again, honestly, it's really, really simple. And you, in the beginning, you can put the formulas next to you and you see how fast you can get to the answer. Okay? Sounds good, everybody? The third one looks like which one? Number 1, number 2, or number 3? Part C, clearly, because it has sine and cos. By the way, class, by the way, you may see cosine first and then sine, then change it, okay? Again, you want to pay attention. Let's say the question was cosine 7 theta, sine 2 theta. You just rewrite it. The fact is it just has cosine and sine involved. So it's the third one, okay? Half of sine of alpha plus beta, which is 2 theta plus beta. And then sine of alpha minus beta, which is 2 theta minus 7 theta. So this becomes 9 theta. The other one becomes minus 5 theta. However, sine is an odd function. So this negative 5 theta makes this minus sine 5 theta. So this is different than cosine. That's why you need to remember whether the function is odd or even, class. Whether it's odd or even. Sounds good? Okay. I'm gonna go to the next. I'm assuming we're done here, class, right? I'm assuming we're done here.
Yes.
We're gonna look at one more example, and now it's the theorem sum to product. It works in the same manner, okay? Okay. If you choose theta to be alpha plus beta over 2 and gamma to be alpha minus beta over 2, you do get to the answer. So it is fairly easy to establish those from here, okay? So sine of alpha plus beta, okay, is 2 sine alpha plus beta over 2 and cosine alpha minus beta over 2. I don't believe I put a question like this for you, but I just want you to see an example of that for now, class. So let me quickly show you an example of that. See how that works. Okay. So we are saying we are interested in going from sum to product. By the way, when we say subtraction is a form of addition. So what is sine of 4 theta minus sine of 6 theta? Okay. So we are going to use, okay, let's give them numbers. 1, 2, 3, and 4. Sine of 4 theta minus sine of 6 theta, and looks like which one of those? 1, 2, 3, or 4?
2.
Number 2. Just use number 2 and you're done. 2 times sine 4 theta minus 6 theta over 2. Cosine 4 theta plus 6 theta over 2. Okay. And just simplify it. And remember with the sign, first of all, this is theta negative, and the negative comes out, becomes minus. Okay, so this becomes, okay, let me put the answer here because the order is messed up, sadly. Okay, so It's negative 2 sine theta cosine of 10 theta divided by 2 is 5 theta. And I hope everybody can see why it's negative, right, class? Everybody can see why it's negative? All right, what about part B, if you will? Part A, use the second one. Part B will use numbers 1, 2, 3. Which one? 1, 2, 3, 4. Which one?
3.
Number 3. So 2 cosine of the sum, cosine of the difference. So they add up to 10 theta over 2 and negative 6 theta over 2. And remember, cosine is even, class. So this part, it's important to see that this is cosine of negative 3 theta, which is equal to cosine of 3 theta. That's why nothing changes, okay? And believe it or not, this is the end of this. This is done. I want to pause the recording and I want to discuss the exam.